Okay, I think we can start the session. Thank you, members who are joining in. I hope we've had the confirmation that I'm audible and we can proceed from there. So my name is Brian Kibichi Kemboy. I'm a software engineering student in Kirinyaga University. I'm also a Gold Microsoft Learn Student Ambassador and a software developer as well. You can connect with me from either X, LinkedIn, or you can see more about me on my website. So, also saying welcome to C Sharp series. We've been hosting these sessions for quite some time now, and I'm happy that we are now having our third session, and it's a good move. So, this is an initiative for us to get to learn more on C Sharp language, and after that, we get to learn how to develop our backend applications. That's most known as the APIs using the ASP.NET Core framework. So today we are learning typecasting. So we shall be checking on typecasting and then later on we'll look on operators. So I'm intending to be giving like at least 1 hour sessions because the more content that I may be able to share, it might uh, be too much for someone to kind of go and learn about them at a go. So when we started the series, uh, I informed you that we have the certification that you can be able to have. That is the C Sharp certification. So it will be very important for you that as we continue with this series, you like go through those modules. At the end of it all, you'll have an exam that you can be able to take. I think it's almost 70 questions. Then you can be able to have that certification. But then you'll have a cert that you can show others that indeed you have a credential that you can show about the achievement that you've made. So let's begin by, okay, I've shared the link. That's the link to the certification itself. It consists of several modules, and I believe that that can take you 2 or 3 weeks to kind of understand the fundamentals very well of this uh, language that maybe I might not cover it very well, and it will be all good. I would wish now to start the session that is typecasting. When we talk about typecasting, it's the process of converting one data type to another. So you remember last week when we were talking about data types in C Sharp. So we talked about those data types that were integers, string, doubles, and today we want to see like at times when you're working with this language, you might want to convert one data type to another. Let's say now, for instance, um, is an example that I gave. You want to convert an integer to a double, and vice. You can maybe go back do a reverse that you want that the double to be converted back to an int. So these are all known as typecasting, and C Sharp is a strictly typed language that you have to show that uh, when converting, let's say from a smaller number that's an integer to a double, it's easy. You don't have to like strictly type that. But when converting back from double to an integer, there's the type you must tell C Sharp that, hey, I want you to kind of cast this because casting is said to be losing your data. Talking about double number, is a double number is a number like 8.333. But if you are casting it back to an integer, it's like I want to lose the decimal values, then remove the integer that is only the 8. So that's kind of what we talk about casting. There's two types of casting. One, we have the implicit casting and the explicit casting. So let's look type and how how what they do. When you talk about implicit casting, this is one of the easiest. It involves converting smaller types to a larger type size. For instance, conversion of a byte, that's always the smallest, to a short, to an int, a long, float, and a double. So these I've talked more about. These are like numerical values, like conversion of from the smaller value to even a more larger value. When we talk about explicit casting, we are talking about converting from a larger value to a smaller one. And I told you this one leads to data loss. For instance, when you're going to convert something from, I think I've repeated this, so it should be the other way around. Let's say now a double back to a float, then to a long, converting long to int, short to byte. So this arrow should be pointing the other direction. So I'm sorry for that by misreading the arrows where they should be pointing. All right. So we should also be looking at boxing and unboxing, like what it is. It's also falls in part of like casting, but boxing by this definition is the process of converting a value type, like for instance an integer, into another reference type. We remember last week also we talked about reference types and value types. Value types are variables like integers. We talk about all these like integers, doubles. Those are value types. They hold a specific value. But when we talk about reference types, there was like an object. You can look at this example that I have. The example says that we can have an integer of, let's say, 35, and you want to convert that integer by converting that 35, that's an integer, to an object. So you can say object, give the name of the object, like how I placed it as the name of the variable, and then you can say that, you can see over here. So this kind of known as boxing, like you're changing from an integer to an object type. So this that's me printing out on the console. So unboxing is this reverse way. Now I want to change back from the object back to an integer. So you see this the bracket that it has, like you have to give it it explicitly tell C# that I want you to convert this object 35 back to an integer. And this can lead to data losses because objects always carries a lot of references, and when you're converting them back to integers, you are losing some data. So we shall be looking into this also in the code. Let's go to the demo, and then we see how that is happening. After then, we should also look on operators, and then I think and then we should also look at the demo on operators. So allow me to share my screen. Okay. Let me stop sharing first, and then share the second screen. I think that's so somebody can confirm that they can be able to see my screen. There's this solution explorer that I've opened from my VS Code. It's what we learned last week. So we can have somebody maybe say in the chat, or can unmute, so I can see some thumbs up to show that can be able to see. Yeah, okay. My VS Code is visible. So last week, these are some of the things that we've been able to learn. And I've also been sharing the link to my GitHub for anyone who wants to go and revisit whatever we've been learning. So allow me, let's start by, I think I'll create a new solution over here. So I'll click on this plus icon for new project. Let's give it some time, I think, because okay, it's here. So I'm going to create a console application. So there are a lot of things that are happening with .NET. You can see we have new things that we shall be looking at when we host our .NET config of the year. We see these things like .NET Aspire. So when you are trying to create these solutions, you can take note of such things. So I'll name my solution typecasting. We can just have them as one word but camel case. So in the default directory, I think it's where it has been created. So it creates the program.cs files and the dependencies. Once you click on it, it shows you all whatever it comes with the SDK itself, and then the program.cs file that we shall be writing today. So give me a minute. I think there's something I'm missing. Okay, I think now I'm well set. So I'm going to clear all this. Once, for instance, you want to run this application, I'm going to open my terminal right on the bottom. But for anyone who is new to VS Code, you can just click on three dots over here, then terminal, new terminal. So I'm going to change my directory back to where we are working today. So if I see we have type system, so I should be able to change directory to type system. Then if I list, I should be able to see you have the value types, reference types. So I've created typecasting. Okay, I think I've misplaced this. So CD to typecasting solution. Why I typed it typecasting. So okay, I'm going to just rectify that later on. So if I try and list, you can see these are the things that it comes with the project solution, the object, the bin that converts to assembly language. So we shall be writing, let's focus only on program.cs file. So we can test the application by running .NET run. So .NET run is going to run our application, and this is just the hello world program. So as that is executing, um, so it always takes a bit of a time when maybe you are starting a new solution. You can see now it's hello world. So allow me clear this console or the terminal, then clear all these as well. So I'll be using the top level statements. So you can see C# supports this kind of writing, but I'll be using the top level statements for this because I would also be using other imported, I will be going to create other classes that shall be able to use. So typecasting, I'm going to write my class program. So class program, let me place this down here. Doesn't matter where you have it. So I'm going to start my main method by saying static void main. The main should be in capital letters. And then, so just also to explain, this is like I'm trying to create the entry point of my application. So this is just a class known as program, but this is the entry point of our application. So I'm naming it static because we don't want somebody else to go and initialize our main method. So by calling it static, nobody can initiate it once again. So let me start writing one of the things that we shall be using. So first of all, I want to give an int, let's say num1 is equals to 100. So this is like initializing a variable. So this is the data type, the int. Let me just increase my font so that you can be able to see it well. So this is the data type. This is the data type, the variable, and the value itself. So this is the value type. When we were talking last week, we expressed this as a value type. It's holding its exact value. So I'm also going to initialize another one that's a double. So I'll call it double num. I'm going to name it num1. So, and you can see from my copilot says this is implicit conversion. Like for instance, I want to change my integer variable. So integer variable always int 32. So it's an integer of it takes some amount of bits. And now I want to convert from the int 32, or I want to convert from the integer. Integers are just numbers, any number that has no decimal places. But I want to convert it back to a double. So I never written double well. So that's the double. So this is the data type, and you should be able to type it very well. So do a console.log, and let me give it a good naming here so that you can be able to differentiate it in the console. So you can see implicit a conversion of a double. So I'm printing out this double value. So it was 100. After implicitly converting, let's see how it goes. So I'm going to run .NET run. So you see, it's a double type. So this is a double type. If you want to check the type, you can just click here dot you can check all its methods that it comes with. I think it's get type. Let me see. Yeah. Okay, misplaced that. Okay, let me look for another method. We want to confirm that it's indeed a double that has been converted to. Is it get type in capital letters? Let me look from whatever we're given. So if that's not the method, I'll just come back to it and then check on the type of the double that we're printing. Yeah, you can see from this. So get type, I think that's when I was writing it, I gave it a small letter, but now get type should be written in this way. But you can see now it's system dot double. So it has been converted from integer to a double. Let's go to this other one. I want to now convert explicitly. Let's say I want to convert a double. So we can have a double value known as pi. For instance, pi is always equals to 3.14. If you want to maybe give one more values, 159. So a double can hold so many decimal places in front of it. So if you want to convert this back into an integer, so you have to give an int. So you can say now this is an int, let's say int pi, and it's equal to, so if I try and let's say convert it direct, like say that into this pi, I want it to convert it back to this other in this other format. So we are going to get some errors. So let's try and see what happens when I miss to give C# that I want to explicitly convert the double back to an int. You should get an error for that. So I'm supposed to, this time around, I'm not getting the type. I'm just getting the int pi. Let's see what it comes. .NET run. So you could see there is some error of this application. Tells you that cannot implicitly convert a type double to an int. You say, are you missing a cast? So when you're reading these error messages, it also tells you that whatever you should do. So to add a cast, you just add some brackets there, and say that I want to convert it explicitly to an int. So once I do this and run the code, you could see now the explicit type is converted. Now it's 3. So we are losing this 0.14159 once we do this. So if you want to get the type of the new pi, so just do dot get type and then save. If I run this, so you could see type system.int32. So it's an integer type at this point. I want us to now talk about also conversion of, let's say, using classes or reference types so that you can see how you can do some other conversions with as keyword. And so we shall talk about the is keyword while doing the conversion. So I'm going to go to typecasting here. This is the solution itself. Just right click or just click on this new file. It's a class. So it's a class of animal. So it's animal.cs file. And this, you can still check on the structure of C#. It first says using system. However, these are top level statements, you can go without it. But this is very important, the namespace. Namespace is what organizes your C# code. So when saying namespace, type casting should be typecasting. It's taking the name of the folder that we are in. And then now you can write some functionalities of your animal class. Let's see what we can do for this. I think for this, I don't have any implementation because I just want to show how you can convert some. So let's just leave it without implementation. So I also want to add another animal, let's say a public class. This time around, I want to add a dog. But now a dog will implement an animal. So we shall be talking more on object-oriented programming, but this just be an introduction. When we did the intro to C#, we talked about classes and objects, but we never talked about inheriting the characteristics of another class. For instance, a dog is an animal, it's innate. By using this sign, like you are implementing or inheriting from the characteristics of an animal. So you can also have another one that's a cat. So that's going to be public class, and then cat. So it's also having the properties of an animal. So this like how you give it. So, and I'm not giving any implementation. If you wanted to write whatever a dog does, then this is the place where we could be able to do it, like a dog always barks, and then write an implementation of it. But for this session, because we're not doing more object-oriented programming, we can just leave it at this point because I would wish to show how you can cast these reference types. So I'm going to ensure that I'm still within these curly braces, and let me come down here. So I want to talk about type casting with the as keyword. So we want to use the as keyword to do this cast. For instance, I want to have the animal class. I can call it animal as its variable or naming. And I want to initialize it by having the new animal. So it's like now I'm creating an instance. So I've created the animal class over here. So I want to create an instance of animal. So just in my program.cs file. So I'm going to first initialize by giving this variable. So this variable naming has our class. Okay. Another thing that we can do. Now I want to make the dog, or let me first do this. Let me like now bring the dog in the context. So the dog is, I'm initializing the dog, so it's going to be animal. So the animal that we initialized is over here. So animal as a dog. So I know this might be a bit complex. So you can remember from our typecasting that we had, we first talked about casting from a small value to a larger value. But this time around, we are talking about this class. This is a parent class known as animal. But now we want now to use this class, then reconvert back to a dog, which is a smaller one. So the animal can have so many implementation or data, but the dog can just have some few implementation. So when casting like an animal to a dog, it's like moving from now a double to an int. So you're moving from something that's too big to something that's too small. So I think that can be a way to explain. Okay, so maybe, for instance, if this cast is not going to work, is the C# code is going to return some null values, especially when you are working with reference types like classes. So if, for instance, this is not possible, we can check it by saying if a dog that we have is not equal to null, that means if it is successful, then now we can say, now I want to console these statements. I can say console.writeLine successfully casted the animal to a dog using the ask keyword. Now, this like now, if for instance I don't get a null, if I successfully converted this animal to a dog, then I'll say, hey, I've converted the dog, the animal to a dog using the ask keyword. Else, we shall get that null in our console. So let's just check if it worked. So I'm going to clear. So this is now casting using reference types. Let's see how it goes. Okay, it's telling me that let me see what it's saying. So we have an error in line 17 saying that okay, I think I get. So we are using, let me bring this back. Are you missing the using derivative for the reference? Okay, yeah. I think I know the reason why, because you don't have the using statement. So we should say using, now this case should be type casing, because all these dependencies that you're using, or this class, is in type casing namespace. So we should be able to use this type casing in our program.cs so that this dog can be able to be, this animal and dog can be able to be accessed. Today my suggestions are not working. I don't know why my extension of C# dev kit is not giving me some hints. I should be able to import by itself. So let's retry. Let me clear and then retry. .NET Run. Yep. So this point, yeah, we were not able to convert. This is because we never printed this. It means that the conversion didn't happen. So it means that we returned null. Maybe I could say now else return null. You could see that this conversion was not as successful. I want also to talk about type checking using the is operator from this point. So I'm going to typecasting using the is operator. So this point, what to just confirm is a dog an animal, or is a cat an animal. So that's kind of the is the is keyword. So you can say animal. Let's say now this is animal 2, because you cannot have the same. So it can be animal 2 equals to the new. This point, let me name the cat because we haven't used the cat. So I would let me just write this to the console because we are printing so many things. Typecasting using this just going to print a statement on our console so that we can know that this is the implementation of whatever, like we are doing the is keyword, so that you cannot be able to get confused with others. Then at this point, I'll say if animal2 that we've created is a cat, let's confirm it if it is. So I'm going to say I'm going to console.writeLine. Animal2 is a cat. At this point also, you can also check on the dog. So the same statement would be executed. So if animal is a dog, so also console.log animal is a dog. That's it. .NET Run. So the first thing we shall see the typecasting. So animal2 is a cat. Okay, why didn't we not have this? Even this should be able to print. So animal2 is a cat. Why didn't it not print the dog? Maybe I never saved. Let's give a try. Okay. All right, so we didn't. Okay, so this is going to be animal2 goes to this dog. So it should be the dog with the small letter. No, Italy, so it's a cat. Okay, let's figure out why the animal itself is a cat. Okay, let's give it let's give an let's initialize. I think because we've not initialized the variable of a dog. So at this point you can say animal3 is a dog. Let's see this. So I'm going to clear, then run. Then you can see now the animal is a dog. So it shows that it is one part of it, but it's part of it because of this. I'm relating the dog back to an animal itself. Okay, let's talk about boxing and unboxing, and then we shall look at operators. So let me go back to my VS Code. Down here, let's talk about boxing and unboxing. So these are just some concept that maybe sometimes you might not find yourself using this. Just that it's good for you to know because you'll find in that certification where you'll be doing it, you'll be able to find it. So and let me first have let me initialize a variable age. Let's say it's equal to 30 or 35. And then next, how to box it, like changing from an integer to an object, like just how we saw from the slides. So I want to convert this int age to an object type. Object type is a reference type. So this is known as boxing. Changing from value type or to this other type is known as boxing. So I'm just going to print because we don't have much implementation for the same. So console.writeLine boxing converted this to an object. Let me see. So this is just going to give object. So if you want to check the type, you just also have to use the get type. If I do this, you're going to see the type has changed from an integer to an object type. .NET Run. Okay, it's still int32, but the type itself is converted because we don't have a system.type. So it's a type, but still in the format of a number. Okay, let me do the unboxing. Unboxing is like now changing from the object back to the object age back to the int. So for this, it's unboxing. So unboxing, so it's still the same thing. So I can say int. I think Copilot is ahead of me. So it's now to change it back, we have to be more explicit first. I want to change from an object, so I should change it direct by giving it in the bracket form. Like now saying, I want to convert this object that we formed to an int, but you should be able to type this very well. Then now you can like console it back. And so once you have it,
Nilikuwa high
you're going
school.
to
So before mu accumulate hiyo rent yote nimelipa. Unless, hey.
yes, Dennis. Right.
Hapana, it's no, it's fair.
I think Dennis maybe is in another call and been able to mute. Okay. So we have some build errors. Let's see what the error is. So the error is in line 50. Let's see. So line 50, we are told that, let me see. So it does not exist in the current context. Okay, I think I just copied the wrong. So let me just, this was the issue. You can see from here, I say unbox age, but I initialize unboxing over here. So let me just change that and then rerun the code. .NET run. Yeah, you could see now it has been converted. So this unboxing command has been executed. So is there anything that I'm forgetting? Okay, there's some other conversions that's always very important, especially when you're dealing with strings. Let's say you have something like this. So a number that's a string. So we can say this is a string number. So at some points when you're programming, you can find yourself having a value like this. It's a number, but type of string. You can always check these things by running console. So string number dot get type. So by doing this, you'll see this something like a number, but it is enclosed in a string. But when something is enclosed in a string, let me still bring this down. Yeah, just below here. So let me clear. So if I'm to run the same thing and get the type, you could see it is type of string, system.string. But now I want to have this string back to an integer. So this is conversion using the convert class. So you can say int. I want now to convert it back to int number because it was a string number. I want to convert it to an int number. So for this, most cases this applicable to whatever. So you can say int first string number as how Copilot is saying, but also want to use the convert class that is convert. I want to convert so to int 32. So and then pass the string number over here. So you've seen the int 32 is something that reference, or it's something that's an integer. So I'm saying convert to an integer. And what am I converting? So this is a method to int 32 is a method, and it's taking string 32 as a parameter to it, so that you can be able to convert it back to a number. So if I'm to get type, so I'm just going to console the same. So to avoid that, I'm just pasting a console, say converted a string int int number to, and then get the type of it. So at this point, you should be able to now have that as a number or an int. You can see it has been converted, so it's a system.int32. Right, so at this point, let me just go back to my slides and then be quick to introduce operators as well. So stop sharing the entire screen and share the slides. So type hashtag operators. So operators is not quite as challenging as typecasting. Typecasting is like a new concept and it applies most specifically to these languages that you have to type them. And let me move the slides to the point that we have. So somebody can confirm that you can be able to see the operator slide on your end. A thumbs up for that if you can see. Okay, or am I audible from your side? Maybe you've not been listening. Yeah. Somebody saying they can't see. My slide is that I'm presenting says, oh, your side has a problem, but I think it should be visible from your side. So an operator. Operators mostly the things that you'll find in programming, and most specifically when you've been doing other things other than programming, you've been doing mathematics, and you've been able to find yourself using these operators, but maybe that was not the name of it. And these are keywords that are used to perform some operations on variables and their values. So operators in C# can be used in a variety of tasks, as for example, arithmetic calculations, comparisons, logical operations, and even more. So I want to have some key points that you should have. And mostly these are the questions that maybe for a new year student, they can be able to be asked what's an operand and what's an operator. An operand, for instance, in this case, we have A and B. So A and B are operands. So, but you can say the values or variables in which you have to perform some actions on them. Then the plus in this case is an operator. So it's the action itself that you are going to take on these two variables. Yeah. So we have several types of operators. So we are going to try as much as possible to cover some of the operators. I know there are quite a lot, like arithmetic, these are like addition, subtraction, all that. So it's very simple. We'll talk about relational operators, the logical operators, the assignment operators, bitwise, unary operators, and tertiary operators. So also you're jumping to the demo, and then after the demo, we shall have completed today's session. So I think next week shall be covering now some of these other topics like now using if statements, control flow structures. But then now the C# language will now get into an advanced level. This is like still beginner level part. So I'm going to share, but now this time around I'm sharing my VS Code once again. So this time around we want to look on operators. So I'm also going to create another solution, just a quick one over here. So create a solution. That's a console app. Let me just search. Here is a console application. So let me name it operators. Let me make sure this time around we are typing the spelling well. It's okay. And then okay, enter and then create the solution. So we have this new folder or a new solution known as operators. You see it comes with the dependencies and the program.cs file. So operators. So we have quite a lot to cover on this, and because it's something easy to grasp, So I'll be more quick in even copying some of the things and pasting them over here. So I'm going to, first of all, so these are the things we shall be covering: arithmetic, relational, logical, assignment, bitwise, unary, and then tertiary operators. So let's begin by the arithmetic operators. So in this case, I'm going to have what is arithmetic over here. Arithmetic is the plus, minus, the multiplication, division. So this is how we represent division. This is the modulus or the remainders. This is the increment and the decrement. So in this case, we want to, you'll be having two variables that has already been initialized to 10 and 3, and in this case, let's perform some of these operations. I'm going to also have all of my code over here and then explain them one by one. So in this case, we have, this is a right line statement. It's just going to tell us we are doing arithmetic operations. So there's this arithmetic operation that is A plus B. These are operands. If we do A plus B, it's like 10 plus 3. That should be 13 in this case. So I think we should be having some guesses over here. Then it shall see. Then when we have now A minus this, A minus or 10 minus 3 should be 7. A times B should be something 30. And then division of A and B, because we have them as integers, it will just take one value, that should be 3. But in other cases, it could be 0.333 and something. But we never said in a double, we said an integer. So it will just cast them by default. And then this modulus. So modulus in this case, we are talking about when I divide 10 divided by 3, a remainder. So we have 3 times 3 is 9. We have a remainder of 1. So we have the result of these as 1. So let's counter check if we are doing it right. So I'm going to go back and then get into the solution. So I'm going to also still go back. CD dot dot is like going back and then ls. So we're going to get into operators. So change the directory to operators. And we have all the files. So if I do .net, first let me clear the cons. If I do the .net run, so you could see that the addition 10 plus 3 is 13. You have 7. Multiplication is 30, 3, and then the modulus is 1. So let's also proceed to another type of arithmetics that can happen. So not arithmetic, but another type of operators. So this time around, we shall be talking of comparison operators. So this, like for instance, if you want to say that if A is equals to B, if A is not equal to something, so the two equal signs means equal. This other one means not equal. This means greater than. This is lower or the less than. This is greater than or lower or equal, and then this is less than or equal. So these are the things that also we'll be able to interact with them and should not be something complicated. So with these ones, I will be more keen on them. So I'll have also the code over here. So this is a statement, relational with the comparison operators. So let's begin with this. So I'm saying equals to. We are using two equal signs, but sometimes you might find yourself using one equal sign. When you use one equal sign, like how it is in this case, so this is like the assignment. We are saying B is equals to A, but if you want to equate them, you should have two equal signs. So that's A equals to B. So in this case, what should I return? It should return false, because 10 is not equals to 3. That should be false. There's this one saying is A is not equals to B. It's true, it's not equal to B. We have A is greater than B. That's true. Is A less than B? No, that's false. And then we have this. Is A greater than or equal to? That should be true, and then 0 should be false. So this adds something quite similar to whatever we've been doing for a very long time. So .NET run, and you could see we found them as we expected. Let's go to the logical operators. I think this is something new. If somebody is new to programming, they have not touched on logical operators that well. So we have these signs that we're using. So for instance, in this case, we have this one, the two, we call them the AND operator. When you have the shift and then shift, I think it's shift 7, you will be having this AND operator. You have these two pipes, which are upright. These are OR operators, and then this other one is, this other exclamation mark is equates to, like, it's not equals to something. It's like it's not. It negates everything. Like when something is true, it turns it to false. That's actually what it does. So I'm also going to bring them here because I don't want to keep typing all these things because they are repetitive. So you can see the first one we are saying X and Y. So we are saying that, for instance, in this case, we are kind of looking them in kind of bits, but it's like saying, for instance, I feel maybe to give a name of a scenario, but is X and Y can they be in binary format? Can they be equalized? They can be no, but X or Y can be true. So these are concepts that maybe you will find them when you're doing this digital logic work. But for instance, okay, I'm using these variables X and Y, and I haven't even shared them. Let me give them here. I think that's why it can bring some confusion. So let me demo how they work. For instance, if we have true and true, true and true is equals to true. But if we have true and false, it is equals to false. So true means one and one is equals to true, and then 1 and 0 is false. But if we are using or, we can say okay, we have the false and false. By default, that is false. So let's look on using or. So we can say at this point, true or true is equals to true. We have this true or false. So if we have one that is available that is true, then it will be true. Unlike using of and, should be true, false, it says it's false. So it's like saying it takes either one. If true is available, it's going to take that. And then the last case is when false and true is true. Then the last one should be false and false is false. So this is kind of an easy way to understand, but there's always a truth table to draw once you want to understand all of them. So and then this other note, it means that, for instance, in this case, X is true, but converting X to the other way around, it's like saying now changing true to false. So that's what this not operator does. Let me run the code and then see how it works. .NET run. In this case, you see true and false is false. True or false is equal to true because we have either one that is true. And then not true, if you convert it, it becomes false. Just easy as that. So let's also see, I think we're almost done. Let's see the assignment operators. think this will be more fast than the time spent on the logical operators. So assignment operators is like now, for instance, when we have something like A is equals to B, or this is like saying now, let B be assigned to A, something like that. Okay, I'm also going to paste its code. I'm going to copy and then have them here. So this is the code. So in this case, I think we had initialized C. No, we don't have it. So we have to have C before working with that variable. So I'm going to say at this point, let's say C is equals to 5. So the variable C holds a value of 5. So it's like saying this 5 is the value of C. So we use this assignment. So first of all, let's console that we are doing the assignment operator. This is just a console statement. So when we say C plus equals to 3, it's kind of saying like C plus 3 is equals to C. So C plus 3 is like saying 5 plus 3. That should be 8. So in this case, we should get something that is an 8. Now C is 8. If I minus 3 is saying by C minus is equals to 3, that should give me 5. This should be 5. At this point, you can say the value of C is 5 here. So it's like saying C, which is 5 times 3 is 15, should be able to get 15. This the divide by, so you can say now 15, which is C divided by 3, should be able to eliminate, I think it's 5. And then lastly, the modulus, now it's 5 modulus 3. This is like saying, now 5 divided by 3. When you do that, the remainder is always 2. So we should be able to get a 2 over here. Let's run and see if that's the case. So if I run the code, yeah, you can see we got everything right. That was assignment operators. Let me proceed to something else. That's known as the bitwise. Or maybe we can leave the bitwise to be the last one because it has some computation of bits. So let's talk about unary operators. So unary operators, in most cases, you might not find yourself using them, but it's also much important to know. So we initialize a variable of f equals to 5. So in this case, it's like now I'm adding. Okay, when you say plus f in this case, so 5 is a positive, so it will maintain it as a positive. But if you are adding negative, it will make 5 a negative. So there's this other one here that is f plus plus. This is saying that I want to add 1 to 5. So that should be 6. However, there's a difference of doing it plus plus and then doing it before plus plus over here. So let's have our first scenario here, like plus plus on this other side. And then the minus minus will always minus 1. So if I .NET run, let's have a closer look. So we have the unary plus, you see it maintains the positive value. But unary minus makes that positive value negative. But when you increment by 1, the 5 does not increment. But if you decrement by 1, you see there's some change. So this is known as prefix and postfix. So this was a postfix. But if I'm to have this plus over here, come this other wing, then have minus this other wing, it will do the computation before consoling them. So in this case, we should be able to get 6. And then in this case, we get, I think it's 5. Let's see. Yeah, you could see now the increment is done when you do it when it's prefix before the variable name. So adding 1 is 6 and minusing 1 is 5. because 6 minus 1 is 5. So the last one, let's look at ternary operator. Also, we're going to have the code over here. You can see this code was huge to be able to type them each one at a time. So ternary operators mostly you'll be able to use, you'll be using it when you're doing, mostly when you want to check on something is true or when certain condition is met. It's a shorthand of if else statement. For instance, if age, okay, we say age is equal to 17 years old, or let me first start with 18 years old. Then I'm having something that should be able to check a string that I've initialized called voting eligibility. So if age, for instance, is greater than, see, we've used this operator as we've introduced. If it's greater than 18, you say this person is eligible. So this is the ternary operator when you're saying that eligible to vote. Else, this other one means else, not eligible to vote. So it's just the console statement of the same. If I want to run the .NET run, so age 18 is eligible for voting. If I'm to do something at age that is less than that, that is 16, for instance, and then .NET run, I will find a value. Let's see. Age 16 is not eligible for voting. It was able to check that statements. So the last one that is always disturbing is the bitwise operators over here. Then we have them. So, and this may this not bother you because you will find yourself not doing it much, but if you will be a system developer, like creating applications, you'll find yourself doing this. I don't know if I'm going to be able to show something here. Let's. Okay, this directory was not able to show me. Okay, but where does bitwise operators work? You find yourself in your computer, especially when you're using a Linux operating system. I think also it always also applies to Windows operating system. There's always a data access to files. Somebody can have access to read, to write, and to execute, for instance. So when somebody has this all access, so you see all. So this is like how this statement always looks like, but let me give it in a shorter hand. So when somebody has the right to do all this, when everything is 1, 1, 1, it means somebody has a right to do this, read, write, and execute a program. But if you do this, this means that you can just read and execute, but in this case, you can read, write, and execute. There's another scenario. When you are doing an 100, it means that you can just read. So this is where bitwise operators always works. And this can be represented using so many ways. So for instance, I think I had a cheat sheet of, let me look for that cheat sheet. Okay, I think it's in the chat. Let me look in the chat. There's something I had in the comments that would help us know these bits. So I think this will be the last thing that we are looking at, and then we can end the session. So I'm going to have it here. I'm sorry, I just picked the wrong link. It's over here. Okay, for instance, if you're having a 1, that's 1 in binary, 2 is 10, 11 is 11, 3 is 11, 4 is 100, 6 is 110, then 7, all the way. We have them up to 100. So there's always a way to how to derive them. So 6 has a representation. You can see that's represented this is in binary. So for instance, if you want to do a bitwise of D and E, for instance, D, let me look at 6. Okay, 6 is 1 is 0, 1, 1, 0. Then down here we have this 0, 0, 1. So both of this both of them same in this case. For instance, if you want to get the solution, so we'll start from this point. If 0 and 0 is same, then we have them as 1. 1 and 0 is not same. It's going to have it as 0. This will be 1 and 0. So in such cases, it's like trying to give somebody this type of access, maybe in real type application. So this person, you could see, has 3 rights. This person can only write but cannot read and execute. So that's what exactly happens. So you can go and read more like how bitwise is used. We have the OR, we have the XOR, we have the bitwise, and the last one that can happen is the left shift and the right shift. So this can be something that you can be able to research, understand bits, and then you'll be able to understand how these things happen at a go. So let me run the last code of today's presentation. So this, like, there are solutions, and I think at this point I'll be able to end this presentation. I think we have been now almost 1 hour. And in case if anyone has a question, you can feel free to ask. Then probably next week when we meet, we do something on we should do something on methods. We shall check on control flow structures. So we'll be having more advanced concepts, and as we move, now concepts get heavy and heavy. But this, I think this marks the end of the fundamentals of C#. If there's a question, so we'll be communicating more on WhatsApp, especially if there's a challenge. So that's where we should be able to have more communication. And I would wish to thank you for attending the session. I think there's somebody who is typing. Let me just wait for that communication. So thank you so much for attending today's session. And if you would want to have some recap, I always upload this on our YouTube playlist, so that if you missed the first session when we were introducing C#, you could still go and rewatch all of them until the point that we are today. So in this case, I'm trying to achieve is a follow-up on a C# kind of a curriculum. It's not specifically guided that you should be completing one after the other, but it's a way in which you can be able to understand C# and then get to develop applications with it. So one thing that amazes me is creating a backend API using C#. It's very easy than any other language, especially when you know the fundamentals. So the frameworks makes it easy to even generate code itself for the backend and get things running. So this is the documentation in case one wants to have access to. I hope that it will help. Okay, then need to say you can't say, I think that was 850. Okay, then what is saying? I think my side has a problem. Okay, I can't understand the context. Do you mean that when you're running the application, or you can't, like, maybe you can't be able to see my screen? And if it's maybe the screen, the recording will be able to have, okay, it was the internet. So if you are not able to see maybe some screen at some point, the YouTube will be much helpful. And also we have all this code is available on GitHub. So If you want to have all this code in your machine so that you can be able to be practicing them, then let me also share that, and then you can end the session over there. So it's this one known as C# series. You can just fork or clone them. There's no problem. Yeah, until that point, I wish to end the session. Thank you, and let's meet next week. Bye bye.